Welcome to Amberbook's 40 Minutes of Competence. How are you today? Go ahead, and what we're trying to do is identify the acoustical concerns associated with this apartment and how would you address them. All right, so what are we to do? Well, there are a bunch of kind of issues, and some of these are a little bit difficult to discern if they're not labeled, but I knew if I labeled these, then you'll you know what the issues are. Just kind of going around from clockwise, this right here is a trash chute, and so anything where you have things clanging and you just have a little wall between that and in this case a bedroom or some kind of a den or whatever, that's not something you want. So you want to move that if you can. This is a washer and a dryer, and they're exposed. There's no door. It's exposed to the living area. And anytime there's mechanical equipment, we need to seal that off. Here we have a plumbing fixture on a party wall. So it's a wall where your neighbor is going to hear when you turn on the sink. That plumbing noise is not that annoying when you turn it on, but when your neighbor turns it on, it can drive people crazy. Just want to make sure that you can hear me. I think you can. All right. The plumbing fixture on this plumbing fixture is on a bedroom wall, which itself is not the worst thing. If your partner is showering, that may not be the most annoying noise, because it turns out that annoyance is not just related to how much noise there is. It's related to things like how intermittent the noise is. Intermittent things like airplane flyovers are more annoying than non-intermittent things. Things that we consider essential, like an ambulance siren, may be just as loud and objectively just as annoying as a boom car or a car that has an intentionally disengaged muffler. But we don't generally find them to be as annoying because we believe that ambulance is there for a reason, and the disengaged muffler is there just to make the car louder and annoy us. The AC is a big one. I lived in an apartment like this. All the AC compressors for all the units above happen to be right there on the first floor. Well, that's normal, but they happen to be near windows, and windows are weak links in the construction. And so the effectiveness of a barrier like this is going to be based primarily not on the SDC or the robustness of the wall, but it's going to be based primarily on the SDC or the robustness of the window. And once the window's open, forget about it. I mean, there's no end to the amount of noise. And actually, these things don't just hum; they intermittently hum. So the person in 4A will turn on their air conditioner, and then with my open window, I will hear it click on. Or even if they're not turning it on, their air conditioner will click on because their thermostat says more cooling boys, and the air conditioning will click on. So this external, this outside compressor condenser unit is going to kick on and off. Same with this one, and same with this one, and same with this one. But that's the way people in Florida do it. That's where I was living in Florida, and even when the weather's nice, they keep the windows closed and the air conditioner on. This is single stud wall construction. And so we're talking about the party wall here between the apartments, and we're talking about the wall that might separate a noisy space like a living room from a quiet space like a bedroom where a child might be sleeping. And generally, we would prefer some kind of redundancy there, maybe a double wall or a staggered wall or a resilient channel. This is a big one. If there's shared air, that's what's written here. If there's shared air, there's shared noise. So if the whole thing is open, then we only have one door between the noisy kitchen and living room space and our quiet bedroom spaces. And if possible, we would like to have things more sealed off, at least from an acoustics point of view. This AC door, instead of having a ducted return, just has a louver. So air just kind of seeps in from the apartment into the closet. And then goes through, and that's of course much less expensive, and you don't have to worry about the hassle and the expense of running return ducts. The problem with that, of course, is that the fan then is from an acoustical point of view, visible to the room. And I really don't recommend that, although it's quite common. There's only one door, so if there's an argument between a couple out here, it's going to pretty easily move in. And this is an elevator that's kind of biting into the apartment, adjacent to the apartment. So we'd rather not deal with that. And then the TV mount is on the wall, so on the party wall. So when your TV is on, especially if you have it loud, because it's on the wall, it's going to impart that sound energy to the wall, and much more of it is going to go to the other room than would be if it was not, if it was removed from the wall and it was just airborne noise that was moving through the wall. So these are our issues. We have kind of generally, we have the issue of shared air. That's probably the biggest issue. If there's shared air, whether it be right here, where the louver door leads to the air conditioning unit, the blower, the air handling unit, and all the air is shared, so you can hear the mechanical fan running, whether it's here with the washer dryer with the no door, or whether it's here with the fact that we only have a partial length wall. We have shared air, and with shared air comes shared noise. Secondly, we want to think about separation. So we want to think about how do we move the quiet spaces far away from the noisy spaces, and how do we make sure that things like plumbing fixtures are not on walls that are going to be shared, so it's some kind of separation. We want to think about common walls, especially party walls, because while people are annoyed by intermittent sounds and people are annoyed by sounds they find unnecessary, people are really annoyed by someone else's dog barking in a way that they're just not annoyed by their own dog barking. So it's much more important, as you might imagine, to, if you're going to be addressing an annoyance, it's much more important to separate one apartment from another than one room within an apartment from another room within an apartment. Redundancy, that's this idea of multiple doors, multiple walls, kind of separating things. The weakest link, the idea that the window, not the wall, is going to be the source of the noise. So focus on that. And then something we don't really ever talk about, which is by quiet, which is that some washer dryers are louder than others, and some air conditioners, either condenser compressor units outside or the blower air handling units inside, some are much quieter than others. So if you want to buy quiet, you've given yourself a pretty big head start without having to do any engineering or design. And you want to always think about the mechanical equipment. I would say there's probably as many complaints about mechanical equipment as there are about the rest of acoustics combined. So people think about, community noise or reverberation time or impact noise, and these are all huge issues. But in terms of the sheer number of complaints, I would say that mechanical equipment is the #1 issue. So you want to get that mechanical equipment thought about early on. You want to think about where it has shared air, and you want to think about buying quiet, and you want to think about separating it, putting it far away from rooms that are supposed to be quiet. All right, now here is our solution. And we'll just go through this as well. So it's the same size apartment. I took some liberties. I moved some things around. So instead of this being a storage room as it was before, I think before it was a storage room like that, or maybe a den, now it's the mechanical room. So it has the washer dryer in it. It has the air handling unit. Now there are 2 doors between the air handling unit and the rest of the space. There's a ducted return in this version. The noisy appliances are in a separate room with a door. The noisy cabinets, dishwasher, disposal, refrigerator, and plumbing are away from noise critical walls. So here I put the things that are going to be clanged like cabinets. We don't want to impart that mechanical energy to the wall. We'd much rather have it be airborne energy to the party wall that separates the two. So before, the cabinets, dishwasher, disposal, and plumbing were on the party wall. So if you ran the garbage disposal in your apartment, people will hear it in the next. In this version, it just flipped around to the other side, and it shouldn't matter too much. And that way we can minimize the likelihood we're going to annoy our neighbors. and more importantly to us, that our neighbors are going to annoy us. The closet as a buffer zone for plumbing and airborne noise. And so we have these rooms anyway that we need in apartments and in apartment buildings. And so in this case, we have closets that we need anyway, and we can put them in between, say, a plumbing fixture that's on a wall that borders a bedroom and the bedroom itself. So we can use them as buffer zones. Likewise, we may have an electrical closet or a storage closet that's needed in the hallway for the mechanical, for the building itself. And we can use that if possible to separate our apartment from things like elevators and trash chutes that have noisy equipment or noisy clanging trash going up and down. So generally we want to think about buffer zones with the rooms that we have to deal with anyway. This is areas adjacent to windows free of mechanical equipment, dumpster, and other noisy outdoor equipment. So here we found some other way. Maybe we have one of the advantages, one of the untalked about advantages of a geothermal system is that we don't have that noisy outdoor equipment. We have a little bit of noisy indoor equipment, but no noisier than anything else we have inside, just because we have a pump. And so we don't have to worry about that outdoor equipment. So not only is it much more efficient, it's also much quieter, and you don't have to look at those outdoor units. Here we have a double stud wall for critical adjacencies. So here between the two bedrooms, between the kids' bedroom and the living room, between one apartment and another, we have a double stud wall. We put the TV on the other side, so we no longer have a TV. I'm sorry, we put the TV here on the other side of the closet. So even if it does go through to the kids' room, at least there's a closet in the way as a buffer zone, and at least it's not bothering the neighbor, or at least our neighbors is not bothering ours. And so we put our furniture on this side, so we no longer have our TV on this side. We put our dining room table on this side, so we no longer have our garbage disposal, our dishwasher, and our clanging cabinets up against the party wall. Importantly, we've now made a second door. So we have a full length wall here and a door in the hallway, and which we had before. You remember we had pretty much the same thing before. I just extended it over and actually sealed it off. And I, like you, happen to really appreciate shared air spaces. I think, mezzanine spaces and kind of open concept spaces are preferable visually and architecturally, and frankly, I think they're probably worth having in many cases. I just think that it needs to be a discussion that's had with the client that says, we're going to open this up because there's all kinds of advantages, but you need to know, client, that if we open it up, it's going to be more annoying to more people. And each person is different in terms of what their threshold is for this stuff. For an acoustician, I'm actually pretty immune to this stuff. The noise doesn't bother me that much. Many other people, it drives them crazy. Double stud wall construction, I mentioned that. TV and stereo, I mentioned that. Double stud party wall, I mentioned that. So full length wall, door to separate living spaces. Now we don't have the shared air. And here we have a vestibule. So if there's a couple arguing out here, there's two doors it has to go through. Because the general rule is, you may be annoyed by the people who live next door to you, but you're very unlikely to be annoyed by the noise from the people two doors down. So it's way better from a cost point of view, from a performance point of view, especially from a performance over time point of view. It's way better to have a vestibule with two doors or a hallway with two doors than to engineer it and say, we're just going to have a noise-proof door, because A, noise-proof doors aren't always closed when they need to be. People leave doors open. B, noise-proof doors are very expensive. And C, because they have gaskets all the way around them, they tend to wear out and they're often not repaired. So you may have it worked out when the door's closed now, but in 5 years, it may be that the gaskets have rubbed themselves kind of raw and are causing problems with the door, and maybe have been removed, or maybe they're just causing problems with the door, so they still keep the sound out, but they drag on the floor every time you open and close. Yeah. All right, that is our review of this particular problem from this week. For next week, we kind of alternate. So I generally alternate between professional competence and technical competence. If you feel like you want more technical competence or you want more professional competence, you can let me know in the chat and I'll try to adjust accordingly. But here's your question for next week. What are each of these labor laws? You're welcome to Google it, or you can wait for us to go over it together, or you can just tell us the ones you know about. But we're trying to figure out how and under what circumstances they apply to an architecture firm. So the FLSA, the I-9, HIPAA, ERISA, Equal Pay Act, OSHA, Workers' Comp, Minimum Wage, COBRA, ADEA, ADA, you probably know something about that, the Civil Rights Act, FMLA, Obamacare, the EEO reporting, and affirmative action. These are all things that affect firms, depending on how big your firm is, kind of governs which ones are affected. But go ahead and see if you can figure out what those are for next week. And of course, we will send this to you in an email. If you're not on our email list, then write to us at firms at amber-book.com, firms@amber-book.com. All right, to answer some questions from last week, someone wrote, it's interesting that the architect hired the civil engineer, because you remember the story last week was a tank that went underneath the parking lot to deal with runoff. And the civil engineer was the one who was determined to be at fault. So interesting that the architect hired the civil engineer. And then someone else wrote, what would it be if the owner had hired him? That's a good question, someone said. Then someone said, interesting, civil engineers are usually part of the designer's work, same as landscape design. Maybe you're referring to a geotechnical engineer. And then someone said, I thought the owner usually hires civil and geotech. And then someone wrote, the Architect's Handbook of Professional Practice, page 605, usually architects consult to both civil and landscape architect with AIAC 401. That's the name of the contract, of course, the agreement. And then in the case the architect hires a civil engineer, it will be a supplemental service. According to B101, correct, it's an ad service. All right, so that was a pretty interesting little chat group, and it touches on two elements of the civil engineer that are a bit confusing and probably pretty important to know. And the first is that the architect, the civil engineer is not part of the base service for the architect. The civil engineer is an ad service, and so the architect is encouraged. You're basically, if you're a consultant, and if your project needs a consultant, and it's not a mechanical engineer, a structural engineer, or an electrical engineer, then generally, not generally, as far as NCARB is concerned and the AIA documents are concerned, you need to check that off as an additional service, and you should be charging more money for coordinating that additional service. So a civil engineer is not part of the base service, it's true, of an architect. And so there's a question, because the owner is in charge of the civil engineer, kind of, or maybe a geotech. And I will try to shed some light on this subject. And it's totally understandable that people are confused about it, because the nomenclature for civil engineers is a little bit wacky. All right, here's how it breaks down. The owner, as you know, if you've been studying for a while at this, the owner is responsible for all things site. So the owner is responsible for surveying the site. So a civil engineer may hire a surveyor or may do their own survey, or the owner may hire a surveyor directly. And the owner is responsible for things like testing the soil. So doing boring tests to determine where the water table is and what kind of soil there is. And the owner is responsible for things like getting approval from the municipality. And these days, getting approval from the municipality often means addressing stormwater kind of before it's even designed, which is a whole big problem, because it allows the civil engineer way too much control over the building. Because a civil engineer will put a placeholder building and describe where the runoff goes, and then the architect is sometimes bound by that placeholder building form, and all the other things that the architect knows about is then pushed to the back, because the civil engineer had already just kind of used a placeholder rectangle, and now the architect has to work within that. Or if she doesn't, she has to go back to the city with the new plan, and that could cost another $10,000 in civil engineering fees. So anyhow, for all the kind of permitting and for all the permissions, the owner would have to hire a civil engineer. And for marking off the utilities. So the owner will hire a civil engineer for locating the water and locating the sewage. And that civil engineer that the owner hires will later coordinate with the architect and say, okay, here's where your water is coming in, here are the issues you need to know, here's where your sewer is going out, here are the issues you need to know. So there are a lot of good reasons that an owner would hire a civil engineer, but there are also a lot of good reasons an architect would hire a civil engineer. If an architect wants to know a little bit more about the soil directly below the building, let's say that the site is huge, and the architect hasn't decided where, when the civil engineer is hired to do the boring tests, the architect hasn't decided how big the building's going to be and where it's going to, where the columns are going to fall. And so now the architect wants to figure out exactly what the soil is underneath this particular column. Well, the architect may hire a civil engineer or a geotech engineer to do more borings, more closely spaced together under the building. If there's a retaining wall that's part of the design, maybe part of the landscape architecture, the architect would typically be responsible for hiring a civil engineer that would deal with the retaining wall. If there's going to be new land contouring that's part of the new design that the landscape architect designed, it's typically going to be the architect who hires the civil engineer to figure out the contouring. The cut and fill is often going to be the owner, so the owner's civil engineer might determine where the cut and fill from the actual building is going to be, but maybe not. That's a little bit fuzzier. So the answer is both the architect and the owner may both hire civil engineers, and they may be the same civil engineer under two different contracts, or they may be two totally different civil engineers, one responding to the architect and one responding to the owner. Now, so that's confusion number one, is that they can both hire a civil engineer, that the owner is responsible for all things site, and many of those involve a geotech or civil engineer, and the architect is responsible for all things that are changed on the site, and that often requires a civil engineer. But then to be more confusing, and this is the part that kind of really throws people, is that there is a little bit of fuzziness and overlap between some of the titles of some of these people. So you may have someone who's a civil engineer who also does geotech work, but they call themselves a civil engineer. Or you may have someone who's does that same exact geotech work, same soil borings, but calls themselves a geotech engineer. But it may be the same person, they may have the same degree. And so they may have different titles just depending on what they kind of specialize in. There are civil engineers that specialize in geotech, and often the civil engineer will hire a sub-geotech to help them out too. So there's that as well, where the civil engineer may hire a geotech or a surveyor. Then there are hydrologists. So there are people who call themselves hydrologists who are really concerned with kind of how water moves on the site. And they may have a civil engineering degree and have the exact same background as someone else who calls themselves a civil engineer and actually specializes in hydrology, or is a generalist and happens to have someone on staff or have some background in hydrology themselves. So there's geotech and hydrologist, and they're both under civil engineering kind of broadly, but you may have someone who calls themselves a civil engineer and does all three, or you may have someone who calls themselves a hydrologist or a geotech. And then there are some civil engineers who actually specialize in foundations. So you may have someone who calls themselves a civil engineer doing some of the structural design and the concrete work of a foundation. So there are a lot of different titles, but just know that an owner almost always will be responsible for hiring a civil engineer or geotech or hydrologist or some combination. And an architect will sometimes be responsible for hiring, depending on how complicated the project is relative to the site. So I know that doesn't make it too clear, but just knowing it's fuzzy somehow makes it a little bit clearer.
Yeah, I had a quick question about the initial problem we did today with the acoustical strategies. So just on the exam, would they ask a question like this, would they be looking for an answer that would be like drawn, like you planned out with a drawn solution, or would it be more so remembering the terms of the strategies kind of, or is that not something you?
That's a good question. I would say more than, in general, the questions I ask on both the Amber Book and on 40 Minutes of Competence are more learning questions. They're on the material that's on the exam, but they're more learning questions than they are example typical problems. So the way it could be asked on an exam is they could say, what's important in noise control between apartments? And they might have a choice that says STC of walls, and location of windows relative to dumpsters, and separation between noisy and quiet spaces. And they may also have other choices that are something like absorption coefficient of materials in the room and total area of absorbing materials in the room. And those are much less important. So that's how they'll ask it, because they have computers grading these and not human beings. But my feeling is that you can understand this. A, it'll help you for your career. B, it'll help you for the type of question that you haven't anticipated. But most importantly, it's actually much easier to remember something by actually understanding it than it is to remember something by remembering it. So if you just kind of know that, okay, these are the ideas. Shared air is a problem. Separation is important. Common walls are the biggest issue. Redundancy is important. The weakest link is going to control the wall. So it's going to be the window or the door, not the wall, that's going to deal with it. And by quiet will never be on the exam, because frankly, that's something that the profession has overlooked. But if you guys are ever in a position of creating questions for the exam, I would encourage you to think about buying quiet, because it's honestly, it's a completely overlooked little kind of secret thing that your acoustician is charging you a lot of money for, but in reality, it's probably not necessary to hire them to do it.
Michael, regarding this, are acoustics, any acoustics dictated by code at all?
Oh, sure. So, and actually not much. I said, oh, sure, but there's really not much. It just so happens that almost all of the acoustics that's dictated by code happens to be for multifamily residential. And so the STC is a sound transmission class. So there's an STC 50, which is required between dwellings. So that's one of the reasons you're going to want a second wall here, is because it's pretty difficult to get an STC 50 with one wall. Now, in reality, I would actually probably shoot for an STC 60. I think you're less likely to have complaints with an STC 60. And also, with an STC 50, it's quite likely, it's not unusual at all for you to design an STC 50, but it only to be measured in STC 40 when it's actually installed, because people didn't seal it correctly. So the STC 50 is what we target. Now, the code allows for a field measured STC, which is also called an ASTC, of 45. Likewise, the code requires IIC, which is impact noise, of 50. So impact noise has to do with footfall from the people walking above you, and that is the worst. In terms of fixing it, that is the worst. And in terms of lawsuits, that is the most common. And so the code requires IIC 50. So a lab tested assembly that someone else has tested, that's IIC 50, or a field tested IIC of 45 as a minimum. A higher number in both these cases is better. Now, an STC 50, I think most reasonably minded people would think that was acceptable. Some people might be annoyed by it, but it wouldn't be considered ridiculous. An IIC of 50, well, a lot of really reasonably, so this one's the impact noise. A lot of reasonably minded people, especially in wood construction, where the IIC does not do a good job measuring the effectiveness of floor ceiling assemblies in IIC. A lot of reasonably minded people will find an IIC of 50 completely unacceptable. And they'll find it totally annoying that the kids upstairs are stomping around, or the dog upstairs is stomping around. And so if you're going to focus on one of them for the test, I'd probably focus on this one. But if you're going to focus on one of them for your career, no doubt about it, this is the one that is the biggest issue in multifamily housing. And I would shoot for an IIC of I mean, it depends what the expectation of the quality is. But I would shoot for an IIC of like 65, which is very difficult to do without carpet. And even if you have carpet, there's no guarantee it won't be ripped up at some future time. It's likely to be. And I hate carpet, and a lot of people do. So if you have a hard surface upstairs, getting an IIC of 65 is actually quite difficult and quite expensive, but nowhere near as expensive during construction as it is afterward. And so that's where I would put my money and my time. Now, an IIC of 65, I would prefer that, and if any of you guys have big firms that want to support some students doing research, we can do some research into this. I would prefer a way to convert IIC number to actual percentage of occupants who consider themselves highly annoyed. So in other words, instead of you talking to a client, an owner, and saying, okay, the code requires 50, but I want IIC 65 because I think it's better, and I think you're less likely to have complaints, but it's going to cost you an extra $750,000, and it's going to delay construction. The owner is quite likely to say, no way. If, however, you said that there was, and let's call it, I'll make up a metric. We'll call it an annoyance factor. So there's an annoyance factor whereby, with an IIC 50, whereby 72% of people are going to be highly annoyed by the construction. You want that, or do you want the annoyance factor where 11% are going to be highly annoyed by the construction? And that one's going to cost you an extra $750,000. I think that's a much easier sell, and it's much more accurate to like helping us understand what's going on. So if one day when I'm king, I'm going to come up with an annoyance factor, and we're going to figure out exactly what percent, not exactly, we're going to figure out approximately what percentage of occupants underneath are going to be annoyed by the people walking above. And then we'll have that conversation, and the code will talk about that instead of just talking about, you know, IIC and FIIC.
Are code part of the exam as well?
Codes are part of the exam, but you don't have to memorize codes generally for the exam.
So they are usually given. I guess
they're usually given as part of the case study.
I heard you mention that most of the acoustic questions are regarding multiple dwellings. Would there be
No, I didn't say that. No, I said most of the code
related to noise?
Most of the content on acoustics in the code is on multifamily residential.
Oh, okay. So anything about performance arts, building,
No,
or hospitals?
Not that I know of.
Theaters?
Not that I know of, except for these classrooms and hospitals have a lot of standards now that many of them have been written in the last 15 or 20 years. And it is not unusual for a municipality or a school district or a hospital or LEED or WELL to reference those standards as part of their internal code or their internal requirements. So I don't know that the International Building Code has something about hospital rooms, but I am certain, or classrooms, but I am certain that they, for instance, LEED for schools does reference what needs to be done for classrooms. And I'm also certain that those standards are, they're okay. They're pretty good.
Anything about, how about exterior noises like construction or airplane noises?
So generally that is,
EPA?
it's more likely to be found in the zoning code than in the IBC. So if you have an area that's near an airport, there may be something in the zoning code that requires some level of exterior sound isolation. But I know of nothing off the top of my head required, and you guys can correct me if you know of someplace in the IBC, but I know of nothing in the IBC that requires exterior walls or that kind of thing. But hospitals, schools, performing arts centers are actually not that big a deal because they almost always hire an acoustician. So there's a professional, there's a third party trained professional kind of doing it. The biggest issues are probably schools who don't hire an acoustician, and hospitals who don't hire a acoustician, or who don't hire a good enough acoustician, because there's a lot of evidence suggesting that getting better quicker is a lot easier if it's not beeping if your equipment's not beeping all night. And if you can't hear the nurses talking at the nursing station and so forth. There's a huge demand for quieter hospitals and for quieter school classrooms.
Hey, Michael, I have an
Yes.
acoustics question.
Yeah.
So which would you say is more important, the entire floor assembly or the floor finish?
Definitely the floor finish. Oh, well, that's not true. I mean, that's a bogus question. But if you put carpet, or like theoretically rubber, which no one does, but I want to one time do a building that just has rubber floors, just to see what happens. But if you put carpet over the whole thing, then the floor finish will get you to is way cheaper and easier to get you to an acceptable level. So you can have a piece of crap assembly and have carpet on top and be fine from an impact noise point of view. Now, you will not necessarily be fine from a noise control point of view, airborne noise control. So the people downstairs, you may hear their TV, or the people upstairs, you may hear their TV, but we're just talking about impact noise from footfall, people walking around. So definitely the floor finish, if the floor finish question is carpet versus something hard. Now, if the floor finish question is tile versus wood, it's somewhat important, but not as important as the whole assembly. Not even close. So that's a little bit of a misleading question. All right, guys, thank you so much. Good luck on your studying, and try to have fun. I know I can tell from every time I can always, of course, the people who are the most miserable are the ones who are asking the questions, but try to have fun with this stuff. It's miserable and it's horrible, but it doesn't have to be as bad as it is. Try to have fun with this stuff and think about all the things that you're learning and how you're becoming a better architect, and try not to beat yourself up if you get a pass, a don't pass, but totally celebrate if you get a pass. So good night, get licensed.